So in section 5.4, we actually start graphing the polynomial functions. This is part 1 of section 5.4. So we're going to use the intercepts and the asymptotes to graph the rational function without the calculator. And again, remember that the graph is always going to start by an asymptote and end by an asymptote in each of its regions. And it is a function, so it must pass that vertical line test when we're all done. So the first one we're going to graph, example 1, is the rational function of the quantity 2x plus 4 over the quantity x minus 1. So let's go through the steps kind of slowly the first time. So the very first thing we're going to do is find the x-intercept. And to do that, we set the function equal to 0. This step we can kind of streamline a little bit. When you go to solve this, you're going to multiply both sides by the common denominator of x minus 1. So it would cancel on the left side. You're left with the numerator. On the right side, 0 times anything is 0. So really, instead of setting the whole function to 0, in this case, because it's a rational function, you can just set the numerator to 0 to find the x-intercept. So it's going to give us 2x is equal to a -4, or x is equal to a -2. And I'm going to keep a running list of the information over here on this side. So we now know that our x-intercept is at -2, 0. Next up is the y-intercept. So step 2, let's find the y-intercept. We're going to replace all those x's with zeros. This is almost something you can do visually without having to write it out. If all the x's are zeros, the first term in the numerator and the first term in the denominator are going to become 0, and we end up with -4, 4 over -1, and -1. So our y-intercept is 0, -4. Okay, now we're going to come in and find the vertical asymptote, and we know that the vertical asymptote from the previous section comes from the denominator. In other words, it's where the function is undefined. Well, this function is undefined when x is equal to 1. So the vertical asymptote is the line x equal to 1. So we'll have a dotted line in our graph as a vertical asymptote. The next step is to find the horizontal asymptote. Again, this is the behavior at the end. So it's going to be what happens over on this side, what happens over on this side, but it's not what happens in the middle. It's only those end values that it's talking about. So again, we take a look at the degrees. So the degree of the numerator is 1. The degree of the denominator is also 1. So our degrees are equal. And anytime the degrees are equal, it's the ratio of the leading coefficients. So for us, the leading coefficient in the numerator is a 2. The leading coefficient in the denominator is 1. That's this 2 over this 1 because the degrees are equal. And that's going to give me a horizontal asymptote at 1 equal to 2. Now, if it's bottom heavy, if the degree in the denominator is greater than the numerator, so bottom heavy, then it becomes the x-axis or the line y equal to 0. If it's top heavy, and we'll do an example of each of these, don't worry. If the numerator's degree is larger, then it takes that horizontal asymptote and tips it and becomes oblique. A reminder that it can have a horizontal or an oblique. It will not have both. So if you found a horizontal, don't go look for an oblique. Okay. Well, that's all the information we need. Now we just have to put those pieces together in order to graph the function. So if you need to, you can always plot more points than what I'm going to plot. But at some point, it's like I said, a jigsaw puzzle. It all goes together so nicely. So we've got an x-intercept over here at -2. We've got a y-intercept at -4. We have a vertical line that's a dotted line at x equal to 1. And again, that's our vertical asymptote, the line x equal to 1. We cannot cross that no matter what. We're not going to touch it. We're not going to cross it. It's boundary line. We also have a horizontal asymptote up here at 2. That's a horizontal asymptote. A reminder again, that's what's going to happen over here at infinity and over here at infinity. It doesn't tell me anything in the middle that's going on. Okay, well, that's what we've got. We've got 2 dotted lines and 2 points. So the first thing we're going to do is recognize that the vertical dotted line, that vertical asymptote, divides the graph into 2 regions. So I have everything that's on this side and everything that's on this side. So this is like region 1 and this would be region 2. So I only have 2 pieces to this picture when I'm all done. So over here on the left side, what we're going to comment on is it's got to do 2 things. It's either going to start above this asymptote or start below the asymptote, because it's got to start by an asymptote in that region. But it's got to get to this point and this point. So it doesn't make sense for it to go up and then do something down. It's going to start right below it, hit those 2 points, and head straight on down. And that's got to be what it's doing. We already know where the x-intercept is. We know where the y-intercept is. In order to hit and go through both of those points, we're going to start right below that horizontal asymptote. Okay, well, what about over on the right side? So here's one piece. This is region 1. Now over here in region 2, what are we going to do? Well, again, it's got two choices. It has to start by this asymptote as I go from left to right. That vertical asymptote is where we're going to start from. So it's either going to start from the top and head like this, or it's going to start from the bottom and head like this. But it's got to get towards that asymptote. Well, in order for it to come up from the bottom and head towards that asymptote, it would have to cross the x-axis again, and we would have another x-intercept. Well, we don't have an intercept anywhere on this side, so it can't be doing that behavior. It's got to start above. So it's going to start up top next to the vertical asymptote and head out towards the horizontal asymptote. And again, if you don't trust that, you can just check a couple of points. You'll find out that that's what's going to happen. And there's your graph. That's it. We're good to go. If the book asks for the domain and the range, you can find that from the picture. I would go find the information, graph it, and then go find the domain and range. And there's your first rational function. So good job. Lots of steps, but they are mechanical. Now we got to do some more.